everyone, welcome to week 7 tutorial. Today we are going to learn about advanced data wrangling with Pandas. This is the table of contents and we are going to run the basics of series and advanced data frame. We are going to move on to the practical exercise, then use polite delay data. And to refresh your memory, there are two main data structures you needed to know within Pandas. The first one is data frame, which we covered in earlier weeks. I believe it's week 4 instead of week 3. And the second data type is series. To refresh your memory, data frames are tabular, column-oriented data structure with row and column labels. So you can think of data frame similar to a table in an Excel file. And series is one-dimensional labeled array, and it can hold any type of data: integer, string, float, Python object, etc. And series has indices and data values, and it is similar to a dictionary because you can map from index value to the data values. We are gonna run what this actually means in today's section. So first over, let's see how we can create a series. A series can be created from a scalar. Scalar basically means a value, a scalar value or integer value, and list, and from a dictionary. And this is the first thing we needed to do to import Pandas library. Okay, it worked. And we are gonna create a series from scalar values. So the first value is the index number, and the second is the data value. Let me clear the outputs first. Clear our outputs. Okay. And because this is just one, this series has only one data value. What if we want to create more than one data values? Then we can specify how many index we would like to see within the series. So in this case, it's going to have 6 index values with a series. Yeah, so these are the indices and this is the data value. And we created from a scalar value of 3. And what if we create a series without specifying indices? Is it gonna work? Yes, it's gonna work. Yeah, by default, indices start at 0 and it goes to length of the array minus 1. So in this example, the index value of this one is going to be 0, 1, 2, and 3. So even though we didn't specify the indices, it starts from 0 and it ends at length of the array minus 1. And what if we want to use an index value other than 0, 1, 2, 3? Then we can put in different values such as 1, 2, 3, 4. And it outputs 1, 2, 3, 4 as indices and ABCD as a value. And this index is in order, but what if we put different numbers that are not in order? So in this example, we are going to put in 105, 103, 102, it's decreasing and it's going up, 109, 104, and 110. We are going to run this code and see if this works. Yeah, it worked. So the index doesn't have to be in order and it's gonna output the same way as we put in as an input. Then my next question is, are the indices unique? Do they have to be unique? So in this example, I'm gonna put in 2, 100, and 2, 102 and see if this works. Yay, it worked. We got 2, 100, and 2, 102, but it still works. So we found out that the indices don't have to be unique. But what about non-numerical values? Can we use non-numerical values as indices? So in this example, I created a list and it's going to be used as index. And as you can see, this index value is a string or Python object. So if it works, then it's gonna have Atlanta as an index and Daisy as a value, San Francisco, Matt, New York, Kelly, Seattle, and Mike. Yay, it worked. So we found out that the indices don't have to be numbers. But what about other data types? Can we use float, integer, negative integer, and positive integer, and a string? Yeah, we use float, positive and negative integers, and a string as indices, and it worked. But this example is only to demonstrate that we can use any type of data as indices, but in the real world, it's more common to keep the data type consistent for indices, because why do we put in floating point numbers, integer, negative integers, and string as indices? And as I mentioned earlier, series is very similar to dictionary because dictionary has a key and value pair. Similarly, series has a index and the value pair. So in this case, this is the key of a dictionary. These are the key of the dictionary and these are the values of a dictionary. And this a dictionary stores how many fruits we have. We have 3 apples, 5 bananas, 2 cherries, 13 mangoes, and 10 peaches. We are gonna run this code and I will give you 5 seconds what's going to be index and what's going to be value. So the key becomes index in a series and the value becomes value in a series. So these are the indices and these are the values. And in the earlier example, the order of the indexes are in order A, B, C, M, and P. But what if we put in different indices not in an alphabetical order? So it starts from mango, banana, cherry, apple, and peach. And as you can clearly see, the order of the indices are not in alphabetical order. Yeah, we can see that the order of the indices is preserved from a dictionary. So whatever we put as an input, it's gonna be the order is going to be preserved. And if we want to know the data type of a series, then we can do that, the type, and it's going to return the data type of the series. Because we've got 13, 5, 2, 3, and 10, the data type is integer. And now I changed the value for the mango, and now it is a floating point numbers. I will give you guys 5 seconds to think about what it's going to return. Yeah, it returns floating point numbers because this is a floating point numbers. And if you try something different like hello, then what is it going to return? These are the integer, this is the floating point numbers, and this is object. So it's going to return an object. Because you can say, no, never mind. Yeah, and if we want to print out indices only, we can use the index property, and it's going to return those indices. And similarly, if we want to print out the values of series only, then you can do values, and it only prints out the value of a dictionary of the series. And sometimes you want to sort the series by index. So in this example, if we want to have the series in alphabetical order, then you can run this code sort underscore index, and now as is sort. And if you want to sort by values, you can do sort underscore values, and now it's sorted by values. And similar to what we did in the earlier weeks, if you specify ascending set to first, then it's going to sort the series in a descending order. And now you're gonna try this section. You're gonna sort the series by index in a descending order. And now I'm going to demonstrate how you will be able to access the element using index. So you can access the element by index number or by index label. So in this example, because we didn't specify index labels, by default it's gonna be 0, 1, 2, 3, 4, 5, 6, 7. So okay, if I do S, then it prints out the series. And if you want to access the element at index 0, it's going to access A. And if we want to access the element at index 5, it's going to return 0, 1, 2, 3, 4, 5. Or you can look at this series and you can tell that it's going to access F. And you can use slicing operation that we learned in the previous weeks. And as you remember, if you don't put in anything in the first position, that means it starts from the start, it starts from 0. And if you put in the second number, this index value, this index number is exclusive. So it's going to return 0, 1, and 2. Yeah, clearly it returns 0, 1, and 2, A, B, and C. And you can try this section later on. And for those cases where we don't have numbers as index, we can use the index label to access an element. So FL is an index, 3 is a value. And because we put in FL as an index, it's going to access the element of this. It's going to access the value of this element. So it's going to print out 3. What is it going to print out? It's going to print out 10. So this is pretty straightforward and it's very similar to a dictionary. And this is very straightforward too. If you use add function, then it's gonna add the two series, and if you use sub, then it's gonna subtract series A from series B, and if you do multiplication, then it's gonna multiply A and B. So these are my series S1 and S2, and if you do S1 dot add parenthesis S2, then it's going to add the two series. So it's going to be 5, 6, 9, and 7. And if you subtract S1, if we do S1 minus S2, it's going to be negative 3, 4, 3, and negative 3. Similarly, you can do multiplication. And this is more intuitive because it's just a plus sign, minus sign, and the multiplication sign. Yep, so we've got the same result as above. And now I flip the order of index values. So in this example, the index A is located at last. So A's corresponding value is 2, and B's corresponding value is 1, C's corresponding value is 5, and this is 6. So these two are gonna match A and A. So if we do S1 plus S2, it's going to find the values at index A. So A plus A is going to be, what is it going to be? A plus A, 2 plus 4. So A's corresponding value would be 6, and B's corresponding value would be 1 plus 1. And C's value is going to be 5 plus 3, it is 8, and this value is going to be 6 plus 5. see we've got the same result. So hopefully this makes sense. Yeah, and we can try something else because A is located here, A is located here. If we append those two series, then it's going to return pecan pie. And because we want to have a space between those two words, I just put in an empty space. And it's going to return pecan pie, apple pie, banana bread, and mango smoothie. And now moving on to the data frames. And for those of you who don't remember the basics of data frame, you can review week 4 material and it covers the basics of data frames. So I'm creating a data frame from a dictionary value. So yeah, it's going to be easier if we just see the tables. So this is what employee table looks like. It's got first name, last name, age, hourly wage, hours per week, and years of experience. And because we've got only first name and last name, I would like to create a full name column. So you can create a column name by putting in the column name within the square bracket, and you can pull the column name from the existing table. So we are going to use first name from the employee data frame, and we are going to use the last name from the employee data frame, and we are going to append those two strings. And because we would like to have a space between the first name and last name, I just put in empty space between the two. And this is how you can create a new column. Now we created a full name column, and it's got the first name, space, and the last name. And if you want to create a numerical column, then you can use numerical operations. Hourly wage means how much its employees get paid per hour, and this is how many hours they work per week. So if we multiply the two, then we can get the weekly salary. And now we just created a column, weekly salary, by multiplying hourly wage and hours per week. And I believe list comprehension is something new to most of you guys. This is pretty strong data manipulation because you can, with just one line of code, you can create a new column. So if you look in here, this uses for loop and this also uses if statement. So if we write that down in Pandas, then it's going to be at least 3 lines of code because it's got the for loop and it's got the if statement and it's got the else statement. So I believe at least it's going to be 3 lines of code. But with list comprehension, you can like squeeze everything within a line. So this basically means that for X in employee weekly salary, so X is going to be each employee's weekly salary. If X is greater than 2,000, it is true, otherwise it is false. So in this example, if weekly salary is greater than 2,000 is true, otherwise it's false. So it's got the first label and it'll get the first label true, false, true, true, false, and false. So this is how you can create a new column using a list comprehension. Yeah, we've got the new column that indicates high income. And as you can see, there are some non-values or unknown missing values in years of experience. In this case, we want to replace those values with 0. So you can specify a column name and you can fill NA values with 0. And because we want to make changes in place, I set in place to true. Okay, even though it doesn't print out anything, it worked. Yeah, so those non-values got replaced with 0. And if we want to replace all of the missing values in the data set, then we don't have to specify the column name. We can just call the data frame and fill NA, and we can do in place set to true. And this is just review of what we did in the previous week. If we want to sort the data frame by weekly salary, then we can do that using search values. Now it's sorted in an ascending order, and all of the high income people are located at the bottom. And this is pretty much the review of what we did in the previous weeks. We only selected the people who have high income. And sometimes we want to drop the rows, and you can use these operations. You can use data frame dot drop, and you can specify the index number. So the index number is the first column in a data frame. So if you know the index number, then you can specify the index number in here. Otherwise, you can specify some Boolean condition that you want to drop, and you can put in index value. You can just type in index, and it's gonna find out the index value of those columns, and it's gonna drop that rows. So I'm going to drop the rows where employees high income is first. So basically I'm going to have only high income people in the employee data frame. So now it dropped the rows where high income is equal to first, and you can see that now it's only got true. Now it's got only high income people in the employee data frame. Just to double check. Wait, actually it didn't get updated. Can you guys guess why it didn't get updated? Yeah, we encountered this issue before in the earlier weeks. If we don't specify in place equals true, then the changes take place only when we call the function, and the data frame is going to remain unchanged. And because we want to drop the rows who do not have high income, then we can say in place is set to true. Then now it's going to have only 3 employees who have high income. Now we move on to the next data frame. This has basically the same information, first name, last name of all of the employees that we previously have in the employee data frame. But it's got an additional information, the company name, Home Depot, Big Project Microsoft, Big Project Disney, Adidas, Home Depot, and 1 non-values. And I'm going to run this line of code, and this data set becomes a data frame named companies. So we've got the information where its employee works. And for those, there's only 1 non-value, but for those non-values, we can do fill NA values with, we are going to replace the non-values with unknown string. So instead of NIN, it's going to have unknown. And because we are making changes in place, I specify in place is equal to true. So now we have replaced non-values with unknown, and let's see if that worked. Okay, now NIN got replaced with unknown string. So this is our current data frame. And in the company column, we want to see only unique names of the company. So you can see that there are 2 Bit Project employees and there are 2 Home Depot employees. So we want to drop those columns, we want to drop duplicates, and we want to see only unique values of those columns. Then now it prints only unique names of those companies. And this function is going to be very useful if you have lots of information. If you have like thousands of rows of data set, and there could be lots of duplicates in the company names. And if you want to see only unique sets of company names, then you can do drop duplicates, and it's gonna help you understand what companies that its employee work for. And if you want to count unique values, then you can do the size function, and it's going to tell you how many employees work for each of those companies. So 1 employee works for Adidas, and 2 employees work for Wipro, 1 employee for Disney, etc. And I just added sort values, and it's going to sort the above function by the values. So this is just an easier way to figure out which company has most employees. And you can do the number of unique values, and it returns 6 because we got 1, 2, 3, 4, 5, 6 unique employers, unique companies. So these are just the help. Those are very useful when working with large and complicated data set. And you're going to be using these functions in the later practicums too. And now we are moving on to joining data sets. We worked with the employee data frames and the company's data frame, and now we are gonna join the 2 data sets to find out which companies those employees work for. So in order to merge, or in order to join those 2 data frames, we are gonna use a function named merge. And this seems kind of complicated, but if you understand what it does, it's not complicated at all. So first over, you're gonna put in the data frame name, and this is the function name we are going to be using, and this is the data frame you are going to join the data frame with on. And specify how we are gonna join the data frame. So it's got inner join, left join, right join, and outer join. And by default, it's gonna select inner join. And I'm going to explain how each join works. So you can specify how you'd like to join the 2 data frames, and join on. So this is column or index level names to join on. This must be found in both data frames. So in the examples of employee data frame and the company's data frame, the common column we have is the last name and the first name. So we are going to join the 2 tables on their first name and the last name. So in our example, the on parameter is going to have the first name and the last name because that's the column names that we are going to join the 2 tables on. And in the case where the column name of the left table and the right table is different, we can specify that by using left on or right on. So for example, if the column names of employee table was first name underscore emp and last name underscore emp, and if the column names of the company's data frame was first name underscore comp and last name underscore comp, then we can specify left on is first name underscore emp and last name underscore emp, and right on is first name underscore comp and last name underscore emp. And the suffixes is used to specify which table each column comes from. So by default, it's set to X and it's set to Y. So if we put in employee data frame first, then employee tables is going to have underscore X. So it's going to have first name underscore X, last name underscore X, and the company's data frame is going to have first name underscore Y and last name underscore Y. And this is going to make more sense if we use examples. But before we apply those parameters into a practical interview example, let's see how each of these merges work. You can do inner join, left join, right join, and outer join. So first over, I'm going to explain the inner join first. So this table demonstrates how inner join works. As you can see, the table A has the city column and the country column. And the table B has city column and the continent column. So inner join will take in the common items or common columns between the two data frames because the city is a common column between the two tables. We are gonna join those two data frames on the city name. So in this example, the on parameter is going to have the city. So we are joining the two data frames on the city, and those highlighted cities are common in those two tables. New York, so is Seoul in table B? No. Is New York in table B? Yes. Is Mexico City in table B? No. Is Paris in table B? No. Wait, yes. And is Sao Paulo in table B? Yes. So those three cities are common between the two tables. So if you apply inner join, it's going to pull the city names that are common between the two tables. So it's got New York, Paris, Sao Paulo, and it's got the country names, United States, France, and Brazil, and it pulls the additional information from table B. It's got North America, Europe, and South America. And this is how inner join works. And now we are moving on to the left join. So this is the left table and this is the right table. So it's going to pull everything from the left table. So it's got Seoul, New York, Mexico City, Paris, and Sao Paulo. So it's got Seoul, New York, Mexico City, Paris, and Sao Paulo, and it's got all of the information from the left table. And we are only pulling in information from right table if there are common items, if they have the same column values. So New York is in table A, so we are pulling this information from table B, and Paris is in table A, so we can pull this information. And Sao Paulo is in table A, so we can pull this information. But is New Zealand in table A? No. Is Cape Town in table A? No. Is Tokyo in table A? No. So we are pulling in information from those columns. So we've got North America, Europe, and South America. And light join is similar to left join. So we are going to pull everything from the light table. So we've got all of the city names from table B, New York, Paris, Sao Paulo, New Zealand, Cape Town, and Tokyo. And we pull everything from the right table. North America, Europe, South America, Australia, Africa, and Asia. And because we are applying right join, we are gonna pull the information from table A if there's match between the table A and table B. So is Seoul in table B? No. Is New York in table B? Yes. Is Mexico City in table B? No. Is Paris in table B? Yes. Is Sao Paulo in table B? Yes. So we can pull only this information. So New York City has a country name, United States, and Paris has a country name, France, and Sao Paulo has a country name, Brazil. So that's how light join works. And outer join will include everything from the left table and the right table. So it's going to pull every information from table A and it's going to pull every information from table B. And if there's a match between the two tables, then we can put in additional information. So it's going to print out everything from table A. So it's got Seoul, New York, Mexico City, Paris, Sao Paulo, and it's got all of the country labels because those columns come from table A. And as I said earlier, it's going to pull everything from table B because New York is already, I'm looking at those columns. Is New York in the resulting dataset? Yes. Is Paris in there? Yes. Is Sao Paulo in there? Yes. Is New Zealand in there? No. So we put in New Zealand. Is Cape Town in there? No. We put in Cape Town. Is Tokyo in there? No. So we put in Tokyo and we pull those continent information from table B. So understanding how these different types of joins work is very, very important because it will help us to determine which type of join will be best to perform in different scenarios. In some cases, you want to pull everything from the left table, then you can use left join. And in some cases, you want to pull everything from both tables, then you can do outer join. And if you want to pull something that exists both tables, then you can use inner join. So by default, it's going to have by default, it's going to apply inner join. Yeah, so it worked. So we've got all of this information and we also got the company name in here. And even though we didn't specify the first name, which column to join on, it worked because it figured that out. These two tables have the common column names, first name and last name. So it worked, and do you guys know why it's returning only 3 rows? Because I can demonstrate a quick example. Because remember, we dropped the rows where employees' income, weekly income is less than $2,000. So we had only 3 employees in employee data frames. But the company's data frame has 8 employees. And that's why it's only pulling in 3 employees information from the company data frame. And if you do right join, then it's going to pull everything from the company's data frame and it's going to have the additional information from employee if there's a match between the left and the right table. So it's got all of the 8 employees information from the company's data frame and it's only pulling in information from employee if there's a match. So as you can see, we've got only John William and Chloe Anderson and Jeremy Scott because those 3 employees have high income from the previous employee data frame. So you can see that there are lots of non-values because they don't exist. Those values don't exist in the light table. Yeah, you can read this description. Yep, and as I mentioned in the explanation, left on and right on is used when the column names are different. And on is used when the same column name exists in both data frames. So we can specify first name. We are going to join the 2 tables on the first name and last name. And as you can see, we've got the same result. And this works because we have the same column names in those 2 tables. But now we are going to use a different example that uses left on and right on parameters. This might happen that the 2 data frames we want to merge have different column names. In this case, we will have to specify the 2 column names. So we are going to join the two data frames using different column names. So the employee column name is full name and the company's column name is just name. So now I'm creating a new column name named name by joining the first name, space, and the last name. So now the company's data frame has a new column name and it's got the first name, space, and the last name. And now I'm going to join the employee data frame and the company's data frame. So employee data frame has a column name, full name, and the company's data frame has a column name, just name. So because those two column names are different, we needed to specify which column that we would like to join on from the right table and from the left table. So as I mentioned lots of times, by default, inner join will be applied. Inner join has been applied, and the resulting data frame shows only 3 rows. And by default, I'm moving on to the suffixes. By default, suffixes x and suffixes y will be added to each data frame. So if you look at this example, you can see that first name got underscore x, last name got underscore x. That means those two columns come from the left table, which is EMP in this case, and those two columns that have first name underscore y and last name underscore y, those two columns come from the right data frame, which is companies. So by default, underscore x and underscore y were added respectively to the left data frame and the right data frame. But in the case where we want to put in different suffixes other than underscore x and underscore y, then we can do underscore 1 and underscore 2. Then we've got underscore 1, underscore 1, underscore 2, and underscore 2. And these are useful when we are using different types of join, because by default inner join was performed. So only the columns that are common in both tables are gonna appear. So it's kind of redundant to have those same columns twice. First name 1, first name 2, last name 1, and last name 2, because they represent the same, they display the same values. But this is mostly useful when we are applying different types of join. So now I'm going to apply right join, and it's going to have all of the information from the company's data frame. That's why it's got 8 employees information, and because there are only 3 employees in employee data frame, it's going to have only 3 information from the first name underscore EMP columns. So I put in underscore EMP columns for the left table, which is EMP, and underscore companies suffixes to the right table, which is companies. So that's why first name underscore EMP has got lots of non-values, and only 3 of them are actual employees' first names. And as you can see in this column, first name underscore companies got all of the employees' information. So those suffixes are useful when you are applying any other joins other than inner join. And the previous example was to demonstrate merge, and join is basically the same. It's got the same parameters other on how, L suffix, R suffix, insert. And I added some explanations. And because everything's pretty much the same as merge, this is going to be very, very straightforward. Only the syntax is slightly different. So we just applied L suffix and R suffix, and it's got L suffix, it's got underscore 1 suffix and underscore 2 suffix. And you can also do Yeah, similar to merge. By default, inner join is performed, but we can do right join. Oh, because I forgot to auto combat. Yeah. So it works the same way as merge. It's just your preference which one to use. You can use join or you can use merge. On to the practical exercise, and we are gonna apply what we have covered in today's lecture. So we will dive into a more complicated data analysis using Pandas from using this data set here. And you can see the explanation in your free time. And hopefully you guys remember how you can read the CSV file. So we are just pulling in those data sets, and we are gonna do read CSV file and save the resulting data set as data frame, DF. So it's got day of month, day of week, unique carrier airline ID, and lots of columns. And as always, we are gonna do head function. And by default, it returns the first 5 rows. And we can do describe function. And it's got the count, mean, standard deviation, mean, 25 percentile, 50 percentile, 75 percentile, and max information. So this is helpful when you try to understand the data set. And this gives you an overview to the data set. So as you can see, it's got lots of columns. It's got 607,000 rows and lots of different columns. I would say 20 columns. And because it's such a large data set, I'm going to specify which columns to use. So this is how you can select the columns to use. You use the double brackets and you put in the columns that you'd like to use within the brackets. And I saved the resulting data set as flight. So we've got day of week, unique carrier ID, origin and destination airport, depart time, departure delay 15 indicator. So departure delay indicator 15 minutes or more. If the delay time is 15 minutes or more, then it's common. Otherwise, it's going to be 0. And arrival time is straightforward. It's arrival time. And arrival delay indicator 15. If it is greater than, if the delay minute is greater than 15, it's common. Otherwise, it's 0. If it's cancelled, then it's 1. Otherwise, it's 0. If it's diverted, then it's 1. Otherwise, it's 0. And distance between the two airports. Yeah. So these are the information that are available to us within the data frame named flight. And this is for you to try a section. You can retrieve unique airlines code. Remember, we covered how you can pull the unique column names using one of the methods that we covered in earlier. And if you do that, there will be lots of airline names, airline codes. So we know DL, Delta Airlines, AA, American Airlines, and maybe a few more major airlines. But do we know all of the unique carrier codes? Do we know all of the airlines codes? No, we don't. So we needed to add another table that has airline names as well as airline codes. So we are gonna do the merge or join with another table that has airline name and airline codes. So flight data frame has unique carrier code, but it's missing airline names. But this dataset airline names .xlsx, which is an Excel file, has airline codes as well as the airline names we need. So we are going to pull this information first. So the airline, this table has the carrier code and the carrier name. And now you're going to use the merge function to join the airline data frame and the flight data frame, and name the resulting data frame as flight airline, and print flight airline and make sure that this data frame has airline codes and all airline names. And you can think of what common column names between the two tables, and if they are the same, then you can just use on, but if they are different, then you needed to do left on and right on. Number 7, I wrote the code and so the flight underscore airline data frame, it's got carrier code as well as the carrier name. So we've got all of the information we need, and now we are going to move on to the data analysis. So we are going to use the group by function to figure out which airlines experience most delays. And this question can be rephrased as find the number of delays by airlines. Right, so it's important to translate the question into data science language. So if you see a question like which airlines experience most delays, then you can immediately think of, okay, I needed to use group by and I needed to use group by functions to find out the number of delays by airline. So because we can group by those airline, carrier code, and the carrier name. You can do either, you can do carrier or carrier name, but just for the convenience, I'm going to put in those two columns. And because delays, okay, there are two kinds of delays actually, departure delays or arrival delays. But for this example, I'm going to do departure delays. And we are going to use the sum because, as you remember, departure delay 15 indicator is either 1 or 0. So if we sum up all of the indicators, then it's going to indicate how many delays each airline experiences. So we are going to sum this column and we are going to sort the values by descending order. So the top first row will be the airline that experienced the most delays. Okay, so these airlines are the top airlines that experience most delays: Southwest Airlines, American Airlines, and SkyWest Airlines, Delta, United States, and those airlines experience least delays. Okay, so if we say the threshold is 10,000 delays in January, it seems that those three airlines are the top three airlines that experience most delays. But oftentimes, passengers would care more about arriving on time rather than departing on time. And that's what airline industries focus more on. Because passengers don't really care if the flight departs like 10 minutes or 20 minutes late, as long as they get to their destination on time. So in airline industries and from the passengers' perspective, they care more about the arrival on time percentage. So we are gonna move our focus to arrival delay percentage. And if we do that, if we use the same threshold, then these are the airlines that experience most delays in regards to arrival. So these are the airlines that have least reliable arrival on time percentage, kind of, right? But this result is kind of misleading because that doesn't take into account the total number of flights. So if you look this example, you can see that Southwest Airlines, American Airlines, and SkyWest Airlines experience most delays. And Delta and United, those top airlines, are at the top that experience most delays. But if you look smaller airlines that are known for not making on time, they are located at the bottom. So this result is misleading because we don't count the number of total flights operated in January. So we are gonna calculate the delayed flight percentage. So we are going to divide delayed flights by the total number of flights, and it's going to give us the delayed flight percentage. So we can do group by, and we are gonna count all of the column numbers. So that's why we are using count instead of sum. So this will give us the total number of flights by each unique airline. So Endeavour Airlines got this many flights operated in January, and as you can tell, like Southwest Airlines were operated the most among those airlines, and Delta was second, and American Airlines was the third. And using the formula that delayed flight percentage is equal to delayed flights divided by total flights, we can divide the number of delayed flights by total flights. And we can just copy and paste the code that we ran earlier. This is basically delayed flights count, and this is basically the total number of flights by each airlines. And now this is a new percentage, and I just added sort values ascending set to first to sort the result in a descending order. So if you look, these are the airlines that have highest delay percentage. So Comair Airlines has 21 delayed percentage, and Alaska Airlines has 21%. And like those airlines, Delta Airlines only 10%, Hawaiian Airlines only 9%, Southwest Airlines are only 9%. So we come up with a completely different result, and I believe this is more accurate and this is not misleading. So those smaller airlines have high delay percentages, while those more well-known airlines have relatively low delay percentages. And this code works. This code is correct, but this is pretty lengthy. So I was wondering if there's any easier way to find that out. And I found that out. There are some easier functions you can do. So because we are gonna use the group by function, and the columns that we are interested in is the same. So we can just do sum and count. Okay, we will learn a shortcut to calculate aggregates using the AGG argument. And everything remains the same except that we replace sum or count with aggregate, sum, and count. So instead of sum and count, we just replace those with aggregate, sum, and count. And it's going to have a new column, sum and the count. And I name this data frame as new data frame. And if you want to calculate delay percentage, then you can create a new column called delay percentage, and you can calculate that by dividing sum by count. And ta-da, we've got the delay percentage, and it's a lot easier to see in this case. Now we are gonna sort the data frames by delay percentage, and we are gonna use sort values by the specific column name. And because we are interested in a descending order, we say this ascending is set to first. And now we've come up with the same result. OH AS34 has more than 20% delay percentage, and those airlines are pretty low in the delay percentages. And our next question is, which day of the week experiences most delays? And this question can be rephrased as find the number of delays by day of week. And to answer this question, we are going to use group by function, because if we group the delays by day of week, then we can figure out which day of the week experiences most delays. But the question is, should we do sum, count, or mean? So the first thing that came to my mind is that we can use sum function. Similar to what we did above, each day of the week is going to have different number of flight operations. So there will be more flights scheduled on Fridays, Saturdays, and Sundays. So if we just count, if we just sum the delay percentages, the delay counts, then this can be misleading. So sum is not the most appropriate function to use in this case. And we can count the number of flights and divide the sum of the delayed flights by count. So this is very similar approach. So this is basically the same approach we did in the previous question. But what if we use mean? Is a mean same as sum divided by count? So we can get the average delay percentage of each day, and this is what we are looking for. So we are going to use mean instead of sum divided by count. So if we group by day of week, we are interested in this column arrival delay 15 indicator, and we are going to take the mean of each day of a week. So we can see that Monday has 13% delay percentage of 13, and Tuesday and Wednesday's got 9%, and Friday and Saturday has higher delay percentages. And to confirm that this aggregate function mean returns the same value as sum divided by count, we can do the same approach, sum divided by count, and see what it returns. Okay, it's got the same result. So if we did a mean, we've got those results, and when we did sum divided by count, we've got the same results. So we can tell that Saturday has the highest delay percentage and Wednesday has the lowest delay percentage. And the next question is, what origins experience most delays? And this question can be rephrased as find the number of delays by origin. And we can use the same approach. We are gonna do origin, and this is the column that we are interested in, because we are dealing with origins airport. It's appropriate to use departure delay 15. And if we are interested in like destination, which destination experiences most delays, then it's more appropriate to use arrival delay 15 indicator. But in this case, since we are dealing with origins, we are gonna use departure delay percentage. And similar to what we figured out earlier, we can just use mean. And we are gonna sort the resulting data set by descending order. So for those origins, it's got very high delay percentages. So we should avoid these airports. And for those airports who have lower delay percentage, this means that these airports are experiencing lowest departure delay percentage, lowest departure delays. Oh, okay. Yeah. And since we don't know all of the airport names from the codes, we can join this series to the dataset that has airport codes and the rest of the airport names. So just looking at those airport codes, we don't know which airport these codes represent. So it's not really useful because we don't know the airport names. So we are going to pull in another information that has airport codes as well as airport names. Okay, this has lots of information as you can see, right? It's got like airport delay, weather delay per airport. So if you would like to play around with dataset, then feel free to do that. But for this exercise, we are only gonna select in airport codes and airport names. So this is where drop duplicates come in handy. So using drop duplicate function, we are gonna find a unique set of airport codes and airport names, and we are gonna save the new data frame as airport names. So I'm going to give you guys a few minutes to work on this problem. I just ran the code, and now airport names got airport codes as well as airport names. And this is what we found earlier to figure out which origins experience most delays. And I just named the series as series. And let's see what it looks like to refresh your memory. So it's got origin codes as well as the departure delay percentages. And now we are going to convert the series into frame because join or merge function works only on data frames. They don't work on series. So we needed to convert the series into data frame. So now the origin delays become the data frame. It's got origin and the departure delay 15%. So to answer the questions that which airports have delay percentages of 30% or more, first over we needed to find the airport codes that have greater than 30% delay percentage. So that's what we are going to do first. We are going to join the resulting data frame to airport names to get the corresponding airport names for each of the airline codes. So just put in the criteria and we are going to find out the airports with most delays. So those are the airports that have highest delay percentages. And if you apply merge or join, and I used merge in my case, my left data set is airports, most delays, and my right data set is airport names. And left data set airports, most delays got the airports codes and its column name is origin. That's why I put in origin here, and airport names. In the airport names column, yeah, it's this one. This is the airport code and the column name is just airport. That's why right on is airport. So those airports have the highest delay percentages and these are the airport names. Oh, I think it's got the Alaska, Oregon, Utah, I'm not sure about TT, Colorado. Yeah. So this is going to be useful, like knowing how this works is going to be useful when you want to dig into a data set of your interest. And this is just a pop-up question. Okay, what if we want to find the delay percentage of a specific airport? Then we can select the origin airport code by using the column by using this criteria. So I'm interested in the delay percentage at San Francisco Airport. Then let's look at the origin delays data frame. Origin delays data frame. Where's okay, it's this one. And because I'm interested in SFO, I'm gonna do origin delays square bracket origin delays origin equals SFO. So that's what I'm gonna do. Wait, it didn't work. Do you guys know why it didn't work? So the key error is on the origin. It's because origin is not a column but an index. So if you take a closer look at this data set, you can see that origin it's an index and it's not a column. If it was a column, then it would have been in the same height. It would have been like origin and it would have like index number like 0, 1, 2, 3, 4 and origin would have been higher up, same as departure delay 15. So because this is an index, that's why it didn't work. So rather than, how do I clear up? Okay, rather than saying, rather than specifying the column name because it's not a column, we can do index. So when the index value of origin delays is equal to SF4, we are going to return that value. So we've got the departure delay percentage of 17. So this is just a pop-up question, and this is just good to know. So sometimes when you work with a data set, you're very likely to get an error message because everything's not gonna work as expected. You're gonna encounter some error messages, and it's important to understand error message and fix your code as needed. So in the case where you see this kind of error message, look for key error and figure out the problems from there. So these are the resources if you'd like to learn more about like each of the data sets and each of the series, merge and join types. Thank you guys all for listening to the lecture today, and feel free to post your question on Piazza or email us if you have any questions. Thank you guys.